Hello and welcome. Today we're going to talk about arc length and the area of a sector. So let's talk about arc length to begin. So the first question is, what is it? Well, if you have a given circle with a certain radius, let's say this circle has a radius of length 5, maybe 5 inches or feet or something, doesn't really matter here. Well, if I were then connect another radius, just a line from the center to the edge over here, it would also have a length of 5. Now in this picture, the arc length is going to be this edge of the circle here, this crust of the pizza. So how do we find this length here? And notice it is not the same as if I cut directly across from this point to this point. That is not what we're talking about. We're talking about the rounded edge. We actually need another piece of information before we can even begin to answer this. That piece of information is, what is this angle theta, right? We need to know the internal angle. Because if this is half the circle, it's going to be much larger than if it's a quarter of the circle, a tenth of the circle, and so on. So we need to know, what's our angle in degrees? What chunk of the circle are we looking at? Let's say, for this example, that we're looking at an angle of 30 degrees. So we have a radius of 5 and an angle of 30 degrees, and we care about this crust here, this little chunk of the circumference, this edge. The way we're going to figure this out is by first thinking of the circumference. You should have memorized the circumference is equal to 2 pi r, or pi times the diameter. Now, if I were to just find the circumference, which once again would be the entirety of this circle, then I would find that the circumference is 2 pi times 5, which is just 10 pi. Now, that is not our answer. That is the answer for the entirety of the circle, the whole crust of the whole pizza. We have one single slice that we're looking at and one chunk of that circumference. Well, what proportion of that is it? That's going to be based off this internal angle. So I'm going to look at this angle and think, well, what chunk of the circle is it? I can actually calculate that directly with the following. I'm going to take this angle of 30 degrees and I'm going to divide it by the total number of angles in the circle. So there are 30 degrees here, and there are 360 degrees in the circle. This tells me, if I simplify a little bit, there are 3/36 of the circle that I care about, also known as 1/12 of the circle. So this chunk here, this 30 degrees, is 1/12 of a circle, which means that this chunk of the circumference is going to be 1/12 of the circumference. So I can actually just continue writing my equation and say this is equal to 10 pi times 3/36. It's equal to 10 pi times 1/12. This is the circumference. All I do is take the circumference and times it by what chunk of the circle I care about, in this case 1/12. So my answer is going to be 10 pi over 12, which is equal to 5 pi over 6. That is my answer. That is the length of this crust here of the pizza slice. So arc length is simply a chunk of a circumference. So instead of memorizing an ugly formula, which you could, I just think of finding the circumference and multiplying it by the chunk that I care about, the fraction that I care about, in this case 1/12. Let's move on and try and find the area of this sector now. So we're going to work with the same circle, the same radius, and the same theta. But this time we don't care about the edge of the circle. We don't care about a chunk of the circumference. We're asked about the area of a sector. What that refers to is this section all inside here. You can think of it as the cheese of the pizza, the inner area of the slice. And so we're going to have to do a different calculation than we did for the arc length. But it's going to be very similar. So the first question I might ask is, what's the area of the entirety of this circle? Well, we know that should be memorized as the area of a circle is equal to pi times the radius squared. And so I can actually just calculate that real quick. That's going to equal pi times 5 squared, which is 25 pi. But that is not our answer. That's the answer for the entirety of the circle, the area of everything. But we don't care about everything here. We only care about one small chunk. And once again, very similar to previously, we're going to find out how much of a chunk. Well, we're going to take that angle of 30 degrees and divide it by the total angle in a circle to find out what chunk of the circle we care about. 30 over 360. That's going to simplify once again to 1/12. And we're still multiplying by 25. Oh, and we got to bring our pi along for both of these. Let's fix that up real quick. This should be pi times 25 times 30 over 360. And then pi times 25 times 1/12. Now we can just collapse it all together and we get this is equal to 25 over 12 times pi. And that would be our answer. Not a very nice answer, but that's how it is. So in order to find the area of a sector, what we'd first do is consider the area of the entirety of the circle, and then multiply by the fraction that would give us what chunk of the circle this sector is. And that comes directly from the angle. Let's try another. So in this situation, we're going to have a circle. It's going to have a radius of, let's say, 7. It's going to connect over here as well. Also a radius of 7. And the other piece of information we need is what this internal angle is, this angle theta. So in our situation, we're going to let theta equal 5 pi over 6. This time we're given the angle in radians. We'll see how that works out. So first we're going to find the arc length. And to do so, we begin by considering the circumference. The circumference of this whole circle would be pi times the diameter, which is the same as 2 pi r, which in our case is equal to 2 times pi times 7. This is going to give us a 14 pi. Once again, this is not our answer for the arc length. We're then going to take that 14 pi and multiply it by the fraction of the circle we care about. That's going to come from this 5 pi over 6 over here. So I'm going to do this 14 pi times a ratio, 5 pi over 6 divided by 2 pi. So what chunk of this is it? What chunk of this is it? Well, I can simplify a little bit. I can cross off some pi's. So 14 pi and 2 pi, cancel those. I can also cross off a 14 and a 2 to give me a 7. So this is leaving me with 7 times 5 pi over 6. Again, the 2 and the 14 canceled. I then cannot simplify this 6 with anything. 6 is a 2 times 3. That doesn't fit into 5 or a 7. So I'm simply going to get 35 pi over 6. That's not a nice and clean answer. We got an ugly fraction, but that is our answer. And so as a recap, all we did was take the circumference and multiply it by the ratio of the radians we're given to the total radians in a circle, which is in fact 2 pi. Let's find the area of this sector now. So for the area of the sector, we'll begin by finding the whole area of the entirety of the circle, pi r squared. That's going to give us pi times 7 squared. This is going to be 49 pi. That is not our answer. We still need to multiply by our fraction based off our angle in radians. So I'm going to take that 49 pi and multiply it by the fraction of 5 pi over 6 divided by 2 pi. Again, the top portion is the angle we have. The bottom portion is the entirety of the circle for angle in radians. Now here I can cancel out some pi's. Pi and pi cancel. I don't see 49 canceling with 2 at all, so I'll simplify one step at a time. So this is 49 times 5 pi over 6 over 2. I can combine the 6 and 2 because they're both denominators. So this is 49 times 5 pi all over 12, 2 times 6. And this is going to give me a final answer of 245 pi over 12. Now, you will usually get a nicer, cleaner number, but it doesn't really matter as long as you follow all these steps carefully. Now, oftentimes in math, you're given a formula and they tell you how to work it forwards, forwards, forwards until you're comfortable. And then they have you go backwards. And we're going to work with one of those situations. So here we have a given radius of 10 and an area of the sector being 20 pi. So this time I know that my radius is 10 and I'm trying to cover some chunk of this circle. I don't really know which, but I'm just going to draw it here for now. And it's going to give us a certain angle. We do not know the angle, so we don't know exactly how much of the circle we care about. But we do have the total area of the sector, which is 20 pi. And so we're going to make use of that to work backwards. So let's think back to how we create the area of a sector. The area of the sector is found by taking the area of the full circle and multiplying by the proportion of the circle we care about. So let's plug in what we know. We know the area of the sector is 20 pi. So I know 20 pi is equal to, I don't know the area of full circle, but I could calculate it. And so I'll do that off to the side right now. The area of this full circle is pi times r squared. In this case, 100 pi. So I'll put 100 pi right here. And then over here, this proportion of the circle is unknown. So I'll just give it an x. Now I'm going to solve for my x variable by dividing by 100 pi on both sides over 100 pi over 100 pi. And this leads me to say x is equal to 1 over 5. Now that's my proportion. I can use that now to find the angle. If your teacher wants you to do degrees, then you would take this 1/5 and multiply it by 360. This would give you 72 degrees. Otherwise, you would take this 1/5 and multiply it by 2 pi radians, in which case you have 2 pi over 5 radians. Either of these is a correct answer. This is in degrees and this is in radians. But I hope you can see that all we did was take the information and work backwards from the equation that we know how to set up normally. Let's try one more where we have to work backwards, but this time with the arc length. So let's check this out. In this situation, we're given a radius of 9 centimeters, an arc length of 6 pi centimeters, and they want us to find the angle theta. So let's draw a little diagram. I'll go to the center. I'll draw a radius of 9 centimeters, and I'll draw another radius. I don't know exactly where to put it. I'm just going to put it at a nice medium distance here. And this internal angle theta is unknown. Theta is unknown. However, I do know the length of this chunk of the circumference. That length here is going to be 6 pi centimeters. And so I'm going to now work backwards from my known equations to figure out what that angle is. As a recap, the way we find arc length is we take the circumference and we multiply it by the proportion of the circle we care about. That's going to look like the following. We have an arc length of 6 pi. We don't know the circumference directly yet, but we can calculate it off to the side. C is equal to 2 pi r, which in this case is equal to 18 pi if we plug in that 9 for the radius. And so I'm going to get that 6 pi is equal to 18 pi times the proportion of the circle we care about. I'm just going to call that x. Now we solve for x by dividing by 18 pi on both sides. X is now equal to 6 pi over 18 pi. This is going to simplify to x being equal to 1 over 3. So I know that the chunk of the circle we care about is 1/3. We care about 1/3 of the circle. But how do we translate that to degrees or radians? All we have to do in order to get a final answer is take this proportion and multiply it by a full circle of degrees or radians. So we can either get 1/3 times 360 degrees to get 120 degrees as our final answer. Or we take that 1/3 and multiply it by the full circle in radians, which is 2 pi radians. That's going to be 2 pi over 3. And either of those is a correct answer.